Okay, let's open this webinar. Good morning or good evening, everyone, depending on where you are at this hour. The topic of today's webinar is a very important one for Auroville, the future of energy in Auroville. But first, let's take a moment of silence to call for Mother Saint Aurobindo's presence. Thank you. As the development of Auroville is finally on the right tracks, it is essential to have a deeper look at the question of energy. We have invited 4 panelists that will help us understand what is possible for Auroville in the near future. Our panelists are Bonke, Brahmanand Mohanty, Ponnusamy Murugesan, and Toine van Megem. 3 panelists are just next to me here in the conference room of the Auroville Foundation, and Bonke is joining us through a Zoom link. Bonke will speak about how Varuna has and can contribute to a sustainable energy future for Auroville. Brahmanand Mohanty will speak about energy sufficiency and efficiency. Ponnusamy will speak about planning and developing the Auroville electrical infrastructure. And Toine will speak about a sustainable energy future for Auroville. I thank you all for joining this webinar, and I thank also Rade and Vladimir, our partner of La Grace Aurobindo Integral Life Center. If you have any question, please write them in the Q&A box, and if we have time at the end of the webinar, we will answer them. Now we'll invite Bonke to shortly present himself and to present his input. Michael, you have 20 minutes. Thank you.
Okay, thank you, Joel. The electricity in Auroville for us, for Varuna, and many others, hopefully, is not only just a physical necessity where we have to work on, but we feel one should, along with it, see that we implement our general principles for Auroville and general principles which one should observe in any case. One of it, which was one of the most important ones, is that we try to make Auroville in terms of electricity totally green. Auroville has now 6 windmills which are producing electricity. Only from one windmill we wheel the electricity to Auroville. The other wind generators, they are partly in areas from where we can't wheel, like Karnataka or so. But in a balance, we are producing much more green energy than the whole energy which Auroville consumes. In addition, of course, we have now starting to have more and more solar energy in Auroville, but still the windmills generate maybe 5-6 times of electricity for Auroville compared to the solar panels. So whole of Auroville is green in terms of energy, even if we are selling partly the green energy to Tamil Nadu Electricity Board or to Karnataka Electricity Board, and we pay with the proceeds the electricity bills of Auroville units. But in totality, with the wind energy that Auroville produces, we are definitely 100% on the green side, or rather, we are producing 150% green energy compared to what Auroville consumes in energy. Another principle which is important for us is that we distribute the energy which we are producing in a non-monetary way. And that doesn't only mean that it doesn't involve physical cash, but no money at all is involved, if possible, as far as we can, that nobody has to pay an electricity bill. It was surprising when we wanted to introduce this moneyless system that there was a lot of resistance against it. People were thinking that it will lead to an excessive use of electricity. But even to our surprise from the Varuna team, it was the opposite. Before we have come with moneyless electricity, that means that at a certain point of time, no Auroville unit, no private individual in Auroville had to pay an electricity bill. We were giving it fully free. Before that, we had seen every year an increase in electricity consumption of 17%, quite regularly the few years before. And everybody was assuming that once we come with moneyless electricity, that the consumption of electricity will increase dramatically, because there was what one would call a hidden demand. Many Aurovillians could not afford an air condition, but would like to have an air condition, but the electricity cost would have been too high. So we were actually expecting, even myself, that maybe the electricity consumption would double or something because of satisfying the hidden demand. But it was the opposite. Instead of 17% increase in consumption, the increase went down to 14%. And that was due to several factors. Mostly, of course, was that Varuna and everybody who was working together, Punnu and Toine, who are speaking afterwards, we were establishing a system that we carried out a lot of energy audits in the buildings. We were advising the Aurovillians how they could save electricity. And also we were trying to create a feeling of a jointly owned commodity where everybody has a sense of responsibility. And before that, it would be that somebody who may have a lot of money and he was consuming electricity and he was paying for it. So he didn't have a bad conscience if he would put the air conditioner on and leave the window open. But once he was not paying anymore for it, and it was a common Auroville commodity, electricity, then of course, these people would have maybe got a bad conscience when they do something like that, because they are not paying for it anymore. They are not taking the responsibility for it, and then they were saving electricity. So in the end, it showed that a moneyless economy could be much more efficient than a money-driven economy. And it's interesting that this moneyless system reverses everything. Usually in a money-driven economy, the producer of something tries to sell as much as possible, to produce as much as possible and push it into the market. And in a moneyless economy, like here we have seen, the producer tries to push as little as possible into the market because he doesn't get anything for it. And he tries to reduce the consumption. So it was a very interesting experiment. Still, some people are maybe a little bit against it, but if one compares it to a family, the social system of a family. Nobody would think that one should put an electricity meter in front of everybody's room to measure how long is the light burning in this one and that one, and then one would exchange money, and the one who uses more electricity would have to pay. The mother had clearly said that there should be no exchange of money amongst the Aurovillians, and we are trying to follow this very strictly. And all the resistance which was there in the beginning, and people who were presuming that it would lead to a higher consumption, now that we have proven that it's working. So I think now we have a lot more acceptance, but once the same thing will come with water, we are working at a desalination plant. Once that will be up and running, then Varuna will, of course, again, not sell the water, but we will distribute it free of charge, moneyless. And I presume that then we'll have again the same discussion. Of course, then we have at least a precedent case that with electricity it was working fine. But it really should be in Auroville that we have a community where step by step we can make it moneyless. And water and electricity are, of course, excellent commodities which qualify for that, because also a possible misuse where everybody is afraid of cannot happen in a big extent. Maybe some people can use a bit more than what they would have used before, but nobody can take the electricity and the water and sell it in the market or something like that. So the green aspect and the money less aspect are very important for us in both electricity and water. And now I'll share a little bit the concept of our vision of how we want to finally supply the electricity and structure the electricity consumption in Auroville. So here you can you see the picture? Sure.
No, not yet.
Not yet. I have it on the screen. I have uploaded it on the screen. You cannot see it?
No. We see that you have started screen sharing, but we don't see the image yet.
Okay, it can take some time, or what is the...
Do you want me to see if I can show it?
Yes, maybe Rade, you can show it.
I can also show it.
Okay, why don't you go ahead, Vladimir?
Okay.
We have a backup, Michael. I have sent your photo to Vladimir.
Okay, fine. So we see here the Matrimandia Lake, where we are just now working on it, which will hopefully come through soon. Then with the earth of the lake, we have to do something. So we intend to have a hill where the mother said that from the earth of the excavation of the Matrimandia Lake, a hill will be made. So the place for the hill is quite clearly determined. It is in the highest position of the greenbelt north of the Matrimandia. There the area is only 5 meters lower than the Matrimandia area. The Matrimandia is the highest point in Auroville. Everything else is lower than that. So this area here is comparatively high, and we intend to have a small lake on top of the hill. This is because when we, in any case, it's clear that we want to run Auroville only with alternative energies. And if possible, then as much as we can, producing it inside of Auroville or very close to Auroville. Here we see a few solar panels. When you rely on alternative energy, then storage is one of the key problems, like also water harvesting. Storage is the key problem. So the electricity of solar panels, they flow in abundance at lunchtime, and in the night, they don't produce anything. So what you require if you want to outbalance this is a storage system. And there, the most efficient system is the uphill power storage. That means at lunchtime, when you have too much electricity produced, you pump up with your excess electricity the water into a higher position. And when the electricity panels don't produce electricity, you let it run down again. This has an efficiency now with the new modern turbines of 90%, which is much, much higher than any battery or any other system of electricity storage. That means you have one turbine which functions as a pump when you run it reverse and you pump it up. And when you let it run down again, then you gain the electricity from it. If we would vary the Matrimandia Lake level only by 30 centimeters, Roger has given as a benchmark maximum 50 centimeter variation of the water level. But let's say if we would vary the Matrimandia Lake only by 30 centimeters, then with 150,000 square meter area, it means that we have 45,000 cubic meter of storage space. And if we would have in a hill with the earth from the excavation, a small lake and a turbine, then this would give already quite a huge possibility to store electricity and rely on solar panels. An even bigger possibility would be if we have a storage lake lower, near to the beach. The difference between the Matrimandia level and the beach is approximately 55 meters of height. So here we would have 55 meters, and then with the hill we have an average height of 20 meters, so 70 meters. And then if we take the Matrimandia Lake into consideration, which also could be used for storing energy, then I think we have quite an efficient mechanism to store electricity, and we could outbalance solar energy produced inside Auroville or inside the Auroville grid, sort of. In addition, we have, as you see here, some wind generators. And what you see here is our desalination plant, which will be the biggest electricity consumer, single consumer most probably. It consumes, when it runs in full speed, approximately between 1 and 2 windmills annual electricity output. Now, when we were laying the pipes here up, we have already laid the pipes till nearly Mango Hill. Then can you show the second picture maybe, which is there? Joel?
Vladimir, can you show the second picture with the pipes?
Yeah, here you see we have purposely not only laid one pipe in the ground from the beach up for bringing our drinking water, but we have put 2 pipes. One is for the drinking water, which from the desalination plant, we will bring it up to Auroville. The other pipe is for an uphill power storage application, so that we can have straight away from the lowest point, from the beach till the highest point at the hill in the green belt, a pipe system where then we can play around with the different elements that when we need electricity from our power storage, we can either use the height difference between the hill and the Matrimandia Lake, or between the Matrimandia Lake and the second storage lake, or between the hill and the second storage lake. So there will be then a system somewhere, there will be a master panel board, and then Ponnusamy or whoever will have to switch from here to there. And we see how we structure our electricity consumption. But for going fully into green energy and trying to be a bit independent, this uphill power storage is a very vital element, and it's widely used in the West. In India, hardly at all. I think there's only one or two in uphill power storages in Tamil Nadu. Toine may know it better. So we think that this would be a good thing for us to implement. So that is in principle our vision. We want to have mostly green energy in Auroville. We want to interlink it with drinking water consumption, with the storage lakes, and see that we become as independent as possible from other energy sources by implementing our own storage system. Okay, so my 20 minutes are finished.
Super. Thank you very much, Michael. That was very interesting. So now, do I have screen sharing available? I will give them the microphone to Brahmanand. Let me just put the camera. Okay, so that's not working. Like this. Yes, so you should click on screen share here, share screen. Okay, and yours. Yeah. Is that good for you? Thank you, Joy. It won't work. It won't work. Okay. Best you just. No, it's not working.
Okay, thank you. It was very interesting to learn about the electricity generation and distribution in Auroville. And I know Toine is also going to talk about distributed generation and storage. I just thought of talking about something slightly different because in general, not only in Auroville, but many other places, we equate energy with electricity. Electricity is just one of the forms of energy that we use. We also need to take into consideration other forms of energy and how do you become self-sufficient in other forms of energy as well. And that is a big task. We are only talking about direct form of use of energy, but not indirect form of use of energy. For example, to get your nutrition, food, you do require energy. For your transportation, you require energy. For construction, you require energy, and all that has to be taken into consideration. So I took up a subject also linked with the present challenges that we have in terms of resource crunch, as well as environmental consideration, greenhouse gas emissions, and climate change. How does Auroville fit into that as well? Because as a city of the future, as a model, what can Auroville do so that others can emulate the same pattern? So I just took up a few slides to explain that. So my topic is, I'll be mostly covering sufficiency and starting with what are the current global challenges. As you can see on the screen, they maybe it's too small. The two challenges that we are facing today is our resources are getting dwindled very fast. On one hand, we are running out of resources because we are using resources at a rate at which the earth cannot really replace it or replenish it. On the other hand, we have challenges of global warming. As you can see on the right-hand side, there's a slide which is showing the projection up to 2100. That is the decision that was taken by many countries who participated in the Paris Agreement, and they all decided to keep the emission level below 1.5 degrees by 2100. But it's a huge challenge because, as you can see on the screen, if you are somewhere here, normal tendency for it to go up, but countries have to make efforts to bring it down. And so far, as you can see, the policies and actions that have been taken by people, you can bring it down to only a level somewhere here. And with that, you would have Earth temperature rising. At present, it's about 1.3 degrees Celsius, 1.1 to 1.2 degrees Celsius is going to rise by 2.5 to 2.9 degrees. And that will be catastrophic in many ways. So the different targets that have been set, you can see for 2030, the target which is set with the present trend, it would be something like 2.4 degrees Celsius, etc. So countries have to make much more efforts. You can see the 2030 target, whatever has been already pledged by the different countries in the national pledges, you will still have a shortfall about 19 to 23 gigaton of carbon dioxide equivalent. But that has come down a little bit after US has joined, has agreed to participate in this exercise. But still, there is a huge gap between what is the emission being created by all the countries compared to what is the pledge to bring it down. So in this context, we'll also have to see the countries, when the countries pledge, it's not only the countries, it is also the provinces, the states, the cities, the companies, and individuals as well. So I'll go through it a little bit more in detail. How do you go to the next slide? No, it doesn't work. Okay. All right. So just wanted to show you also the impact of COVID lockdown. We all had this experience 2 years back. All of a sudden, we were not prepared for it, and the whole world faced this challenge. And as a result of COVID-19, many activities stopped, particularly the production activities, the transportation activities, and all that led to, as you can see again on the right-hand side, the type of drop that we saw in carbon dioxide emission per day. And it's about 8%, in 3 months average is about 8% drop. And the peak drop was about 17%, which is quite unprecedented. So make was just to, we saw the type of havoc we had to, which stopped all the activities, and the drop was only about 8%. And it was actually recovered within very short time. So imagine if you want to bring it down to the level that has been pledged, or that is the level that you want to bring down to avoid the catastrophes that are forecast, then we need to make much more efforts than what we have been doing so far. Now, this shows us the per capita emissions. And this is interesting because you can see the areas that have been shown is the total volume of emission that is by the countries. And you can see US, China, India are the biggest emitters here. But whereas when it comes to per capita, because of the population, per capita emissions are much lower, for example, for India, China compared to the US. So there's a big disparity between per capita emission in the US compared to what is there in India. And the reduction targets that are there for each country is going to be very, very different. So going back to the previous slide that I talked about, this is the challenge that we have set ourselves. That is how we reduce our emissions per capita trajectory from somewhere between, let's say, 4.5 to 5 tons per capita per year. We need to bring it down to 3 by 2030, something around 2 by 2040, and 1 by 2050, which means we need to bring it down by almost a factor 4.5 within the next 30 years. And that's a huge, huge challenge, because as you can see, in many developing countries, the trend is still upwards. Very simple reason, because the consumption is very low, and you need to bring up the consumption of people so that they can have a better quality of life. So you can see the disparity that are there, that is shown here in this slide. I've just taken, there are 5 countries shown here, 2 industrialized countries and 3 emerging countries like China, Brazil, and India. And you can see the average is somewhere around 4.5. So you can see China, Brazil, and India are still below the average, whereas Japan and Finland are higher. But if you see the target for 2030, US has to bring down by something like 73%, almost a factor 4. Whereas in Japan, it's about 2/3. In China, it's about 1/3. India, it's A 2030 target, there is no challenge as such. But when it comes to 2050 target, even a country like India has to bring down by about 45%. Okay? So these are huge challenges, particularly for a country where there are still a lot of people below the poverty line. But when you talk about the average figure, for example, in India, it's about 2 tons per person per capita. But it is a statistical figure which is aggregating all the emissions from the different people. And a further study which was done in India shows something very interesting. The average, this was a survey done in a particular area, region of the country, and they took the samples of people with different earning power. This is the last one. The last column is people who earn more than $5 per day, whereas the first column is people who earn less than $2 a day. And you can see those who are at the base of the pyramid, their emissions are very, very low, less than 0.2 tons per capita per year. Whereas those who are at the top of the pyramid, it's 1.3 tons per capita per year. And as you may have seen in many cases, during the pandemic, actually the rich became richer, whereas many of the poor suffered more. And their income actually dropped, which means along with that income, their emission also dropped because they didn't have the purchasing power, they didn't have the minimum required to have a decent living. So these are the things that we are facing today, which can be summarized in the next slide, where I talk about the 3 tensions in our current lifestyle. The first one is we are behaving as if we have an infinite resource. Okay? In a finite earth, we are looking for infinite growth, and that is a big challenge because our resources are limited. The second one is you have seen the disparity between those who have and those who don't have, and there's a huge socioeconomic dichotomies that has to be addressed. And the third one is we are trashing all that we consume, and the natural sink overload. Because of that, we can see the impact in terms of the pollution, solid waste pollution, air pollution, water pollution, etc. And that also is a big challenge for all of us. So this is based on our current lifestyle, which is based mostly, Michael talked about the economic driving everything, and he talked about Auroville going beyond the economy. We have a money-led system. So with the economic system, the economy actually remains the operating system of our society today. Everything is bound by economy. Everybody talks about the gross domestic product. The GDP is the driver for it's a yardstick to know how the country is faring. Okay, so you can see every country, including India, trying to see how we can have higher GDP, but that does not necessarily shows the right picture. Okay, because the economy in this case is showing how we can meet our needs and wants. I wanted to emphasize on these 2 words. There's a difference between needs and wants, and how do you take care of both? And that is a challenge. For some, it is basic needs, those who are at the base of the pyramids, whereas some who are at the top level is more of their wants. So how do you change the model? Because we know that we have limitations somewhere in terms of environment, in terms of resources. So our limits are actually not the money growth, but the physical natural boundaries that we have, the resources that we have, the level of emission that the earth can accept or the globe can accept. So we need to reframe the whole thing, saying that we should not be driven by the economy, but we should be driven by our physical and natural boundaries. Okay, so that all our resources are actually there for the service of the society, and they also help us to lead towards sustainable living. So the model that we have, the challenges that we talked about, the 3 challenges, how do you convert into 3 principles of sustainable lifestyle? The first one is to accept that we have an ecological limit. That means you have consumption within the economic limits. How do you create a more equitable world? How do you reduce the gap between those who have and those who don't have? And the third one is, of course, the well-being of people. At the end of the day, how do you achieve the well-being of people? Okay. So once we adopt these 3, we accept these 3, the model is going to change a lot. because then we will know that we have a specific space, okay, where we say there is a fair consumption space, which is shown as a box here. And below the box, the floor is showing what is the social minimum required for people to have a decent living. Okay? We're talking about fair living. What is the minimum level required for people to have a decent living? So those who are at the base of the pyramid, they're actually under consuming. How do you help them to bring it up to certain levels so that they have a decent living? On the other hand, all those who are over consuming, particularly those who are well-to-do, and this is definitely not sustainable from the environmental perspective as well as for the resource perspective. How do they reduce their consumption so that they keep themselves within the environmental limitations that we have in terms of resource? That we saw that the ecological footprint of many countries are exceeding. You can see the quota of resources that is available. In many countries, we are already exceeding, we are borrowing from the future, and that cannot go on forever. Okay? So in this fair space where the main areas where we consume and we require resources for our consumption is for food, transportation, and housing. And these three actually are accounting for almost 2/3 to 3/4 of our total resource use as well as the emissions, plus the consumer goods, services, and leisure. And this is more of an issue for industrialized countries where these are much bigger, whereas in developing countries, our main focus is more on food, transport, housing. Okay? So keeping that in mind, how does Auroville set a good example of being a city where we ensure that there is a minimum level which is achieved so that we are within the fair consumption space. At the same time, we don't overdo, we are not over consuming, because that way we are not setting a good example for the others to follow. So keeping that in mind, I come back to my topic of sufficiency. Sufficiency is defined as a set of policy measures that you can undertake or the practices that you can adopt to reduce the demand for energy, material, land, water, all these natural resources, and while delivering a decent living standard for all within the planetary boundaries. So a sufficiency approach will actually support the fair consumption space that I talked about in the last slide, through a range of options for housing, for transportation, for thermal comfort, for nutrition requirement, food. Okay. And sufficiency is an integral, is very important for the process of meeting the universal needs. And Michael also talked about how do you ensure that everybody has access to energy. It's not just energy, all forms of requirements, whether it is food, whether it is mobility, etc. And by limiting both overconsumption as well as the under-demand of all these resources, it becomes central to the global climate mitigation strategy. We don't have to really struggle automatically. Once we control ourselves, we will all, so that the two things that we're looking at, how do you bring down the overconsumption on one side, and how do you help those who are at the base of the pyramid to go up, so that there is a mid-path met, so that that is something acceptable for the earth and it will be more sustainable in the long run. Now, it raises a few questions. Okay? The current approach to the climate change mitigation that we have adopted, there's a lot of optimism saying that technology itself can take care of everything in terms of bringing in efficiency, bringing in high-tech in information of Internet of Things, etc. That is going to help us to really reduce to some extent. But unless we also consider the lifestyle changes, and the lifestyle changes are very, very important. The second one is on the behavioral change over the systemic change of the economy. Many things are being tinkered with the economy, looking at new business models, but that's only going to take us that far. We are not going to achieve the ultimate target that we have set in terms of resource use as well as environment as well. Okay. And the last one is everything is based on cost benefit analysis. And cost benefit analysis, we're talking about monetary terms, and you need to go beyond that to talk about how much biophysical reality of the planet we can handle, so that there is a good balance between the resources that we use and the emission that we create. Okay, so obviously you can see sufficiency is not something which is perceived positively by the wealthiest consumers, because that will force them to bring down the consumption pattern. and that is not something which is acceptable for people those who are affluent. Now, a little bit of definition of sufficiency. I think I've covered many of the points here. Going back, I suppose. Yeah. Okay, so the principles are how do you achieve the sufficiency? First thing is to moderate the speed to enjoy life. You know, there is a way some people are adopting a lifestyle as if there is no tomorrow. We need to understand that, you know, the world must continue. It doesn't end with our generation. There is a next generation and so forth. So how do you bring that moderation in the speed that we enjoy life? The second is to reduce the distance between the supplier and consumer. So you go for more local as much as possible. And Auroville in that sense is already doing a lot of things in that direction. Limitations of trade to focus more on commons. And again, Michael talked about more on commons. Don't only look at the commercial aspects of it. Okay, limitation of goods ownership, going away from cost benefit analysis over again looking at the biophysical reality of the planet. So all that we do, we need to keep in track of what is the resources that we are consuming and what is the emission that we are generating in the process. Okay, and if you want to implement the principles in reality, we need to bring in structural changes. Obviously, there's certain things that can be done by behavioral and lifestyle by individuals, because the individuals account for about 22 to 2/3 to 3/4 of the emissions. But it's also determined by the governance system. It is determined by the structural changes that are necessary. By structural changes, I mean, how do you set up the infrastructure right from the beginning, which will help you to automatically reduce the need for all these resources. So infrastructure needs are particularly relevant for developing countries because we are in the process of creating the infrastructure. If you take the wrong direction, we are tied up with the wrong infrastructure for a long time, and that will be a catastrophic for developing countries, and we'll never be able to bring it back to low level. And there's a flexibility to allow for the usership of services, going away from the notion of ownership to getting services more and more, what we call as the servitization, going away from consumption to provision of services, and of course, adapting the size and the use of goods and infrastructure to evolve according to the human needs. So focus more on human needs and not wants. Now, some studies have already been done, scientifically, researches have been done to see the sufficiency requires a real metamorphosis to fulfill the human needs with the minimum remaining carbon budget. We have seen that our carbon budget is shrinking with time. The more we delay, the more challenging it will be for us to keep ourselves within the limitations that we have set. So these are the studies that have been done by 2 studies I've taken here. The floor area per capita is very important. You can see 30 meters square per capita, whereas the decent living energy is something like about 15, it should be decent living demand. It should be about 15 meters square per capita. Housing operation energy demand, housing thermal comfort in terms of heating in cold countries, cold climates, and cooling in warm climates, nutrition, mobility services, all these numbers are there. One can go through it more in detail later on. The point I wanted to make was, it's not just enough to say that you provide the services. We need to have some benchmark. We need to have some numbers to follow so that we are conscious about the way we are using energy. Like in the case of Auroville, you can already see, I had gone through a study where about 20% of the consumers account for about 60% of energy, which means there is a challenge. We do have this similar problem as those who are consuming more compared to some others who are consuming much less. I'm coming to almost my end of my presentation. I didn't want to give too much emphasis on efficiency, which is already pretty well known. Today, we are looking at, this within the span of about 30 years, we have found ways by which we can reduce our consumption by about 4 times, 5 times, and 10 times, what you call factor 4 to factor 10. That means it's possible to improve the efficiency in such a manner through technological innovations, by which we can reduce the need for resources by anything between 75% to 90%. Okay. But the problem is, once we have chosen the wrong solutions, if you go for efficiency, we are going to consume more and more resources for making the systems the technological innovations, we do require more and more resources. So efficiency is going to help, but a combination of efficiency and sufficiency is going to take us a long way, and combined with, of course, our search for alternative forms of energy, more benign forms of energy like solar, wind, etc. That will be covered by my other colleagues. So I just wanted to give you examples of efficiency. These are day-to-day, our daily life examples. We have, for example, started, even today, there are many people who use incandescent bulbs with coal-fired power plant. How can you have a shift just by changing from a incandescent lamp to, let's say, compact fluorescent lamp? You can already have a factor 4 improvement. Further with LED, you can have a factor 7 improvement. And if you decide that time to have your energy generated locally with solar, you can have an improvement of factor 18. So you can see solutions are already there. Auroville is already practicing many of them on a day-to-day basis. Similarly, if you go away from, let's say, oil-based transportation, mobility, if you change to electric vehicles, we already have an achievement of factor 4. Further, if you go for solar, then you can bring it down to something like factor 14 improvement in terms of efficiency. So these are already there. I just gave 2 examples due to paucity of time, but I could cover much more on efficiency aspects. But this is becoming more and more mainstream now. We need to look at how do you address the challenges of sufficiency. Otherwise, whatever we do in terms of efficiency and renewables, we will not be able to reduce our consumption. So just to give you an example of practical solution with which I will be ending, I've taken the case of transportation. One is to look at how do you reduce in absolute terms, anywhere with high impact consumption, for example, flying and driving, you can reduce the level of flying and driving. And this is showing us the graph of emissions, for example, with car, airplanes, motorcycle, bus, rail, bicycle, etc. The first thing that we can do is to see how do you reduce in terms of absolute terms, how do you reduce our consumption or emissions from flying and driving by driving less. The next one is, of course, the efficiency improvement, which is going on all the time. We can see efficiency improvement is showing on the y-axis. We are constantly improving our cars with new models that are coming up. The planes are becoming more efficient. The buses are more efficient. The two-wheelers are more efficient, etc. So we are already achieving some sort of efficiency improvement. But combined with that, we need to bring in some modal shift wherever it's possible. If you can switch from, let's say, from car to a little bit more of bus or go to bicycle, we are going to definitely have much better situation. So it's a combination. It's not just one. It's a combination, and modal shift comes with the sufficiency, and it's more related with the behavior and lifestyle changes. Obviously, giving an example of bicycle, in developing countries, one of the challenges is that we don't have the infrastructure which encourages people for going on bicycle. If you take Netherlands, for example, you have designated bicycle lanes, you don't have air pollution, etc. Whereas in many developing countries, you just try to encourage bicycle, it doesn't work in the long run because of these infrastructure challenges and the environmental challenges as well. So we need to take that into mind so that we ensure that there are policy changes which will also support the shift away from driving to more public transport or riding bicycle. And with this, I will end my presentation. I think I've overshot my time by a few minutes. Thank you for your attention. I hope that this will give some impetus for us to have some discussion over this, because Auroville today is hardly about 3,000, 3,500 people. When you are going to extrapolate to 50,000 people, we'll have to think about how do you develop all these, not only in terms of renewable energy and distributed generation, but also look at the direct, indirect consumption of energy, whether it is transportation, it's in food, how do you address all those together? Then it makes real sense to see that people can look forward to Auroville as a good model city, which can serve as a beacon of hope for other cities to follow. Thank you very much.
Thank you, Brahmanand. But we are going to show Ponnusamy's PowerPoint also. I would just like to remind the audience that you can put your question in the Q&A box, So feel free to share any question. We will reply them at the end of the webinar. Now we'll give the microphone to Ponnusamy and here. Oh, it's okay. And I'll share your this one. They say it doesn't work. This one, they're done?
Yes, that's the one. That's the one.
Yeah, this is the one.
Yeah. Yes.
You see, it shows like this on me. But then there's no, you see. Okay. Can everybody see the PowerPoint? Yes, Michael,
Yes.
you can see.
We
Yeah,
can see.
okay. So then I guess we're good to go. You can click here for to go to the next slide.
Okay. I'm going to talk about the Auroville electrical infrastructure in work in progress today. I'll go to the next. Electrical infrastructure as it was developed, you can see originally it was started growing unplanned infrastructure, like, unsafe, and sustainability was not there. Different difficulties. A lot of people were wanting to do what they want, and they were not listening to any of the planned way of doing and all that. So the basic principle of laying underground cable infrastructure came much later in the picture, and often we were asked to do a cheaper way of doing the infrastructure because they want to save money. That was the main reason. And all the time we have to fight. We have to say that, it is not the way to do it, but still people wanted to insist on going for cheaper possibilities and cheaper way of doing it. Very low density development makes infrastructure cost per capita very, very expensive. And TNB lines crisscross everywhere in the master plan area was very, very hard for us to get rid of it in the end. So we were really fighting so much to get rid of the lines. And you can see in the next slide, this was the case when we had lines going crisscross everywhere in the master plan area. Overhead lines, actually the overhead lines were coming from Murumbai substation, 22 kV line. And it just goes all around Auroville and continues, up to the villages around and non-master plan areas and all. And then, especially in Auroville, in the master plan area, we had such a lot of LT lines, low tension lines, which were supplying also electricity to outside, non-Aurovillians in the village and all. And then we had to deal with them, and we wanted to get rid of all these lines so that we can go for underground infrastructure. But it took us quite some time to achieve this. And this is the result of what we had in the Toine time. And we had a lot of damages. We had about 40-45 days without supply, and we had to redo everything. And actually the TNEB chairman visited the Auroville infrastructure, and he advised us not to go for overhead line at all, because it's being a coastal area, he wanted us to go for underground infrastructure. That's when we started going slowly for HT underground cabling and LT underground cabling. And this was the big mess we had, and then we had to deal with it for nearly 2 months to get the supply back. Actually, we were one of the earliest supply restorers in this area before Kadalur and Pondicherry. Quick reminder: this is the EHT voltage 630 kVA, 400 kVA, 230 kVA, and 110 kVA. And standard HT voltages are 600 kV, 33 and 11 kV. And standard LT voltage is 230 phase to neutral and 415 phase to phase. need for change. The TNEB overhead lines, I mean, we really wanted to get rid of it because, it was a big mess. We had to clear the granaries all the time. And we were also facing a lot of problem with the neighboring landowners. And they didn't want us to cut the trees. And we want to have the clean supply without interruption, but it was not possible at all because we always had some problem with the neighbors and also with the Aurovillians. And so that's when we wanted to go for underground system and all. The HT distribution voltage of 22 kV is non-standard voltage, as you know. The standard voltage will be often, we always end buying 33 kV equipments for using it for 22 kV. So obviously the cost of the equipment was very high. The HT distribution voltages 11 kV will be much lesser in cost, and also the space of the transformers required will be very minimum, and we can manage, and the cost also will be reduced. Actually, the sample, we can have it in Pondicherry. Actually, we can see they have shifted from 22 kV to 11 kV recently. And the whole of Pondicherry, I think it is working with 11 kV instead of 22 kV, because the 22 kV supply is non-standard voltage. Actually, we were paying much more. Till now, we are paying very high for buying the transformers and equipments, because it is 33 kV system equipments, we are paying much higher. The electrical master plan concept design, we have made it in 5 different categories: electrical HT distribution plan, electrical LT distribution plan, road and street lighting master plan, park and green zone master plan, lighting plan. All that has been worked out by electrical master plan. Was DCL, who created this master plan for Auroville, and they have categorized in 4 phases. The first phase for 5,000 people, second phase for 15,000 people, the third phase for 25,000 people, fourth phase for 50,000 people. And you can see the calculative capacity: 5.6 megawatt, 12 megawatt, 20.6 megawatt, 48 megawatt. This translates into an average installation of installed distribution capacity of 0.96 kilowatt per capita. Electrical master plan executive summary. Distribution voltage will be, for us now, we are trying to get one substation built very close to Auroville, and it is in the pipeline now. We are having some issues with the land, and eventually when we get that substation, we'll be getting 11 kV feeder, one feeder for us, and the rest will be working for the rest of the areas in the other towns like Potagopam, Malayachavadi, and all the other areas. And even when we have this substation in place, we have the alternative energies like solar energy and other renewable energy and sources and all. And we need to have definitely reliable connection to have public electricity grid still needed for us, because we have to still manage with the public grid. That is must. We cannot avoid that. The Auroville master plan layout leads itself well in the installation of HT ring main along the circle. It is the crown road, what we started to lay the underground cable along the crown road. We have almost laid up to say 70% of the ring. We still have to complete another 30%, and only then we'll be able to penetrate into the all the radials so that we can go into the other zones. Now we are a bit stuck with the electricity backbone cable, because the cable laying work has been stopped since some time now, and it has to go on. so that we can complete the backbone in order to do the development for Auroville, for all the other zones. Safety equipments, voltage drops, level of producing longer and lengthy cables we want to reduce. We want to go into clusters with the HT cables so that the drop can be minimized. With the LT cable, we have to reduce the LT cable length so that we can have the sufficient amount of electricity running in the. These are the kind of switchboards we are going to use. Power control centers for a different usage, residential, industrial, and agriculture and town infrastructure services, low tension distribution. A smaller load will be done to 450 volts feeder filler and boxes. Now comes the renewable energy sources will also be an essential part of Auroville's electrical energy system. This will include grid connected solar PV generation and energy storage system, because we have put a lot of solar energy system everywhere in the rooftop to reduce the electricity import from grid and use it in our building, and whatever is left over will be pumped in the grid so that we can compensate with the energy consumption of Tamil Nadu Electricity Board. So we are also introducing lights. All the normal lamps has been replaced with the LED lamps so that the electrical consumption will be reduced. So these are the kind of transformers we are using now, dry type, instead of using oil type, because the oil type transformers will be dangerous later. We can't dispose the oils when it gets spilled out. So we want to use, if at all we want to use oil type transformers, we want to use biodegradable oil filter type so that we don't need to spoil the environment. So this is the ring feeder layout we have created. So we have actually put 5 distribution transformers in the city area. So we still need to go long way because we have got only 5 transformers. We have planned for actually 17 numbers, where the industrial zone is totally left out and educational and the cultural zone is also left out. We have covered only one portion, sector 1 and 2 in residential zone. We have covered whole of Bharat Nivas, and we have covered some of Centerfield area and other Aurodam areas, but Matrumadir and all, it's covered, but we still need to go for more transformers in order to supply electricity to other zones of Auroville. 11 kVA town feeder. Oh, yes, yes. This is how we want to get the cable laid and get the distribution developed in Auroville for the master plan area. There it comes. This is one state grid, another one from the other side. Ring main 11 kV along with the ground road connected at 2 or more points, like we have shown in the slide. And we can go up to second stage of our electricity distribution, but that third stage will be 110 kV. Definitely we need to go for. I think so. This is internal electrical distribution. Again, energy efficiency, low voltage drop. Connected reliable energy systems. What we are doing is, with the whatever surplus is coming from the solar panels will be pumped in the grid when it is high. Whenever the grid supply is, the solar panel supplies are low, then we always take it from the grid, so that it always compensates. Yes, I'll just go for the slides so that we can. This is our internal electrical distribution. Energy metering. We have gone for bidirectional meters. You can read the import and export active. Yeah. Using Auroville modes. Energy metering audits. Energy consumption feedback loops. Remote monitoring from the office. We can do remote monitoring all the clusters of all the meters and all with the help of Ornico optical fibers. Already done grid connected solar PV. We have done a 500 kilowatt of solar grid connected solar PV. Off grid solar PV, we have about 300 kilowatt wind turbines, wheeling facilities since 25th of May 2016. We have this facility. Already done the municipal energy plan for future installations, April 2003. Code of practice. We have a code of practice in Auroville, which was created in 2020 version released. Service corridor designs, electrical master plan, development consultant. They have done a master plan for us. March 2014, they have done it for HC. May 2014, they have done it for the LT part. Already done. Clusters already included in the Auroville distribution system. Aurobindo, we have given supply with the HT network. The administrative area, that is where we are sitting now. Town hall, Auroville Foundation office, including nearby residential buildings, part of residential zone, that is 1 and 2, and Bharat Nivas, Centerfield area, language lab, Aurobindo nursery area, we have covered with the HT networking cabling system. Auroville distribution transformers installed near Aurobindo. One near Sukhavati, we have residential zone 1 transformer. Near Arka, Crown Road, we have 1. At Bharat Nivas, inside Bharat Nivas, we have 1. Near Town Hall, we have 1 transformer. The total transformers, we have 500. Total of 500. TNB LT service connection has been dismantled because we didn't want to have the TNB meter here, and we have our own meter, bidirectional meters, so that we can have our readings taken remotely from AVS itself. Planned for 2022-23 installation of 110/22/11 substation by TNB, 11 kV receiving station, 11 kV cable from receiving station to Crown HT ring main. This is what we want to have it already last year itself, but this has not happened due to some land problem. Clusters planned to be included in Auroville substation system. Visitor center, we need immediately attention because they are overloading now our LT cable. First part of international zone, they are also wanting to have our system because they are also having problem with our TNB transformers and TNB network. First part of educational and cultural zone, they are totally they are stuck now. They can't do any development with the existing TNB system. So to complete all this thing, we need funds. We need to do the work so that we can progress in development of electricity networking. Renewable energy generation, standalone system, grid connected solar PV system already operational, additional solar PV generation. So we have created also smart mini grid phase 1 and phase 2. The capacity you can see, the PV capacity of phase 1 is 130 kilowatt. Phase 2 being implemented with the additional 200 kilowatt of solar PV system. Energy storage is also happening here and there slowly, and we need to go for energy storage additionally more. This is where we have this mini grid where we are sitting now in this area. Smart mini grid in operation. All of admin area is covered with solar panels. All the rooftops. Thank you.
So Toine is joining us now. Stop share. So which one goes? This one goes.
Maybe we can manage it without seeing next slide. Just a suggestion.
Oh, yeah, you are seeing both slides, correct? This is what you're saying.
Yeah, you just have to end the slideshow and just do a straight PowerPoint like you did the first one.
Okay, so like this then.
Yeah, perfect.
Here down? No, then
Yeah.
I have this. Right?
Whoops, no. Yeah, now we see two things. We see the next
So-
slide. And so if you go, yeah, there we go. This one is the best. No slideshow, just like
No
this.
slideshow. You prefer
Yeah.
this? Okay.
Yeah, otherwise we're seeing two things and the main slide isn't large enough.
Okay, so that will work for you?
Yeah, thank you. So good day, everyone. Good day, good evening, good morning, wherever you are. That's a quick one.
Yeah, why? Sorry, why are we seeing
This is the
now?
previous presentation, looks like.
Yeah. So do you see a PowerPoint called a
Yes.
sustainable energy future for Auroville?
Yep, looks good.
Okay.
Then something in the dial screen.
Yeah, so go ahead. Toine.
And how do I change the slides?
So you just go here and you can
Okay,
right bottom left.
yeah. So a good day, everyone. I'm going to present on the sustainable energy future for Auroville in the broader sense. And before doing anything, I would like to share a vision document that we had drafted many years ago, where we basically say what is the vision that Auroville should have or would have for its energy. And first, of course, is that energy will be consumed as a means to achieve a higher level of consciousness, which is the whole purpose of Auroville. That Auroville will be consuming energy only from sustainable sources. That to the extent that Auroville uses energy from non-sustainable sources for the building of the town, that such energy will be compensated for, and that a change of consciousness and the transformation of matter are essential to achieve ultimate integral sustainability. So this is a vision document on the basis of which the rest of the presentation is prepared. So what do you want to achieve with a sustainable energy program? You want to achieve, of course, uninterrupted quality electricity or energy for all. You want to source it from a mix of sources. You have to store it because it is not always there when you need it. You want to save energy with conservation and efficiency measures. You want to establish a demand and supply flexibility. You want to have a resilient system. You want to create awareness among the township residents for responsible management of the resources, energy resources. And then energy budgeting and accounting to be an integral part of Auroville's in-kind economy. So what is the strategy to achieve that? It is a mix of many things. One is you would like to maximize as much as possible the on-site renewable energy generation. You would like that you distribute the sources of energy. You would like that load generation and storage clusters function as subgrids that may operate in island mode when required. You also would like to make it modular and in such a way that it is made up of clusters that can be interconnected. And just now, Ponnusamy has shown you how that works in terms of the grid. The grid which is modular and where energy can be generated almost anywhere. Now, the next slide I'm going to do very fast because actually Brahmanand has already covered this subject. The subject of need versus greed, energy conservation, energy efficiency, renewable energy and fossil fuel usage. These are all to be done in parallel, but the top one is actually the one that Brahmanand addressed very well, need versus greed. Now, of course, need versus greed is very subjective, but I think most of us agree that if you enter into a five-star hotel in Chennai or Pondicherry, you don't need 18 degrees centigrade in the lobby, right? You're coming from outside 36, 37 degrees, you're quite happy if it is a few degrees lower. So that is not even need versus greed, that will be need versus stupidity if you ask me, right? So we have to first define what do we actually need. And then comes the question of how can I meet that need in maximum, as much as possible with natural resources. For example, if I need 300 lux to read, can I at least in the daytime get that 300 lux from daylight and don't close the curtains and read with artificial light? And then comes the question of efficiency that Brahmanand has also nicely addressed, and of course, the renewable energy. So what Brahmanand depicted in a different way is he also shown that if you have 100 units of primary energy on the left of this picture to give light to one bulb, and suppose that is an incandescent bulb, you have all these conversions from electrical to mechanical and then transmission and distribution. If you would just change that bulb from an incandescent, not even to an LED, but to a CFL, you get a factor of 4 reduction. So that has already been addressed very nicely by Brahmanand. Now, the electricity consumption in Auroville, we have taken data from the electrical service from their metering for the period 2012-13 financial year to the just concluded financial year of 21-22. And this is all electricity consumption. So domestic, agricultural, wherever we have been able to meter it. And what you see is that there was a per capita increase from 2012-13 to 2019-20 of about 76%. That's a huge increase per capita because the proper way to measure is per capita, not the total. And then we saw that 76.2 came down to 49.4 and 49.96, again with reference to the original year of 12-13, maybe by a combination of factors, one of which could have been the corona crisis, but there might be other factors as well. So we got a bit worried that the consumption per capita is going up and we need to do something about it. Now, if you look at solar, which is one of the renewable energy sources, not the only one, the nice thing about solar from the financial point of view is that once you make the investment, the capital cost, the cost per kilowatt hour is almost fixed for 20-25 years. Because the only variable cost you have on top of the capital cost is the O&M, the operation and maintenance, which is very low in the case of solar. Whereas the conventional energy, it goes up at least by an inflation factor of about 5%. So you see on the top of the curve, of the top of the graph, you see the curve of conventional energy projected to the future. And then you see, of course, the solar being more or less horizontal. And that delta between these two curves is what your financial benefit is, apart from all the other benefits if you go for solar energy. Now, we have to look in the future also that it is quite likely that more electricity is going to be consumed for a good reason, namely that transportation will move increasingly to e-mobility. Cooking, which in Auroville is still done very much with gas bottles, may also move to electricity. So what we did is we made a table, and we, a little bit arbitrarily, we choose 3,000 kilowatt hours per person per year, assuming that mobility and cooking will also shift to electricity. If it is not, then the number will be lower, but just as an exercise to see what you get in terms of numbers. And then what we see that in terms of storage in megawatt hours, with a 3,000 kilowatt hour per person consumption, what is needed? And then we put both of these together into a cost implication table. So what you see here, that let's take the third row in this table, 15,000 population. With 3,000 kilowatt hours per person per year and 4 hours of storage only, which is very little, you would have a solar energy capital cost of 122 crore. For the international audience, a crore is 10 million rupees. So 122 for the solar capital cost, 51 for the storage cost, and then total of 173. So we have done this all the way up to 50,000, just to get an idea about the type of investment that would be needed. And mind you, 4 hours of storage is very, very low. It's insufficient, but just to get a taste of what you're talking about. And Michael has already spoken about the pumped hydro storage, which also will be part of this whole storage strategy. So what is the area you require? Now, what we always believe is that you should first use the roofs. Don't use land for solar. Land should be used for agriculture and for other purposes. And actually, it is interesting that if you go for a population of 50,000, with the consumption that I have assumed, which is high, for the reasons I have given, you need just 37.5% of the entire roof area of Auroville for solar energy. And you could use the rest for urban agriculture and other purposes. So it is doable that the entire energy that needs to be produced, if you go for on-site within Auroville renewable energy entirely, can be achieved with just 37.5% of all the roofs. So what are the other considerations while you plan this? First of all, you want flexible load and flexible generation, because the nice thing about solar is that it is peaking in the middle of the day when many loads are also peaking. So that coincides. But what you can also do, of course, you can run, you know, a washing machine or something which does not have to run at a particular time of the day. You can run those when the sun is shining, right? Same thing with cooling. Cooling is needed at the most in the middle of the day when the sun is shining. So what we have done in one project, which we call the Smart Mini-Grid project, we have actually installed also meters where we can do remote demand control. In other words, we can switch off non-essential loads when the solar energy is low. So that is another option we can implement on a larger scale. Now, what are the future trends in solar energy? Oh, what happened? The other presentation came back on my screen.
Yeah, I think if you go back to this one, right?
That one, on the right side. Yeah. So what are the future trends? One is a combination of PV and air heat exchanger. It's really picking up in Europe at the moment, where you not only generate electricity, but you also have a heat exchanger where you basically pick up heat in the daytime that you can use in the night or in the winter, and you store it somewhere. So then demand side management solutions where you, as I said earlier, you can either remotely or totally automatically switch off non-essential loads when you have a demand supply gap. So instead of having load shedding, what is very common, you would have a load reduction only. There is a new trend also of lightweight solar panels, which are 100% recyclable. People have always asked a very valid question. What happens at the end of the economic life with a solar panel? There's aluminum in it, there's glass in it. And now there are a few companies who have developed solar panels which are very light, number one, and where the entire material can be recycled. So that is a very promising trend. This picture was already shown by Ponnusamy. This is a project which we have started in 2019, where with an initial grant that we received from a generous corporate donor, we installed a lot of solar, in the meantime, about 300 kilowatt. And because all the buildings in this picture are connected to the Auroville grid, we need not match the solar capacity on top of the roof of the building with the requirement of the building, because the surplus just flows into the grid of Auroville. And electricity has a very nice habit that it always takes the shortest path to the nearest load. So if building 3 in this picture would have surplus and building 2 next to it has a deficit, it just flows to building 2 right next to it. So by having an internal grid, which Ponnusamy has elaborated on, you get an advantage that all the roofs together become one big virtual roof. And your whole matching problem is gone. If you have an individual connection, you have to be careful, because if you put too much of solar, you may have export to the grid, which may not be financially interesting. And if you have too little, you have a deficit. But here we don't have to worry at all. We use every shade-free roof area available, put solar in it, knowing that that surplus deficit problem gets solved by this being integrated into the overall Auroville system. Now here you see an interesting graph. So this is a typical day curve, load curve of Auroville for that part of Auroville which is connected to that internal grid. So that is basically large parts of the township area, the city center, all the areas that Ponnusamy has already mentioned. Now you see one line, the light blue, which is below 0. Now that is that smart mini grid which you saw in the previous picture exporting to the rest of Auroville. So that means that between, say, about, 9:30 in the morning and 4 o'clock in the afternoon, that area, this is the town hall area as we call it, or the administrative area, generates much more solar than what it needs. It goes through the high tension ring of Auroville to other parts of Auroville. And as you can see, the overall load of the whole system is about to also go below 0. If there would have been a bit more generation or a bit less demand, we would have been exporting to the public grid. Now, what do you do with this? If more such clusters are installed, so not only town hall, but residential zone, international zone, then more and more curves come below 0. Then the total curve, the cumulative curve, will also come below 0. And that would be the time when you start putting that surplus into storage. And when you have stored energy, you could then flatten the morning peak. You see this morning peak on the left, you see the evening peak on the right, and you could flatten those peaks by utilizing the storage with energy that you have taken in the daytime. So that is called peak shaving, and it is also known as peak shifting, because you can actually shift the peak to a time that it is more convenient to you. Of course, the ultimate aim of this whole exercise, as I explained in the vision slide, is that this whole curve would be completely 0 in terms of taking from the grid, that you are actually generating all the power on site from your own generation sources. So what is the conclusion from our studies and work done so far? Is definitely Auroville can achieve a sustainable energy future. The distributed and connected renewable energy generation and storage systems. The connected part is very important because you could also think, why not have distributed systems which are standalone? So the idea of connecting the clusters is that no cluster, no building and no group of buildings will have at any given time exactly the same amount of consumption as it has generation. It will happen maybe once in, by pure coincidence. So at any given time, there will be clusters in surplus and there will be clusters in deficit. And by connecting them, you basically balance that out. So that's the first point. The second is utilize the net avoided cost of grid power to install additional renewable energy. Because as you have seen in the earlier slide, we have a long way to go. We need a huge amount of capital to be invested. So what we have done in the case of that smart mini grid, as an agreement with the grantor, that whatever generation takes place, the money which normally would have gone to TVB goes into installing additional systems. And it works a bit like this, that if you install today 100 kilowatt in that model, after 20 years, that becomes 300. So when the first 100 kilowatt is about to be retired after 25 years, a new 200 is already functioning. So that way you make it also economically sustainable. And of course, the last point is obvious, target for 100% renewable and zero carbon energy future for Auroville, starting from, we have put a target of 2025 to achieve that. And that requires a lot of investment, but we want to make a sincere attempt to achieve that. Auroville is inside Auroville, within the campus, by own generation, carbon neutral by 2025. That's it. Thanks.
Thank you, Toine. So I suggest we go straight to the question. So Dave, maybe you could make our three panelists here on the same frame, and okay, and whoever feels like answering. So the first question that everybody can see on the screen: what kind of water will be pumped through the second pipe between the beach and Auroville? So I guess this is a question for Michael. You have to unmute yourself, Michael.
Yes.
Michael, you need to unmute yourself.
Now you can hear me?
Yes.
Okay. One pipe is clear, that's for the desalinated water, which we produce in the desalination plant, and then that will participate in the drinking water supply for Auroville. And the other pipe, that will be water which is from the storage lakes, which will be filled with rainwater, harvested water, or even excess water from the desalination plant, for example, in monsoon time, when nobody waters their gardens, then maybe, and when there is a lot of rainfall anyway, we may have excess water available, which means we could reduce the production of drinking water. But if over the year we then would fall short of water in the summertime, we can let the desalination plant still continue producing fresh water, and we fill up all our storage lakes, which we can let them go down then in summertime a little bit. So the type of water which is in the storage lakes from which we will use as a electricity storage by the way of turbines is a mix of all the water which is not 100% drinking water. One could call it maybe gray water or whatever, which is used otherwise for irrigation mostly or whatever. But this mix can be a composition of different sources, even of desalinated water, but mostly rainwater, harvested water, or processed wastewater. Clear?
Yeah, thank you. We'll take the next question. So from M. Yoop, long being evident, Auroville needs transport train system to move around Auroville. So I guess I'll complete the sentence. We should lose the motorbike, taxi, and auto options. Perhaps the ring road or the crown roads could be used this way. This is Vern from in the USA. Somebody feels like.
Yeah, definitely. I mean, there is a plan for a hop on, hop off electrical bus already for the crown. There have been plans also for a tram, but we don't have the population yet, I think, to justify a tram. So definitely the crown is an ideal place where you can have a public e-transport, and then people can, get off at the radios and maybe take a e-two-wheeler to go to the places. So the answer is 100% yes to this question.
Let's move to the next one. Question from Jyoti Prasad. Why are we still depending on TNEB for our energy needs? Offering prime land near a visitor center for ugly looking TNEB substation at the main entrance of Auroville. Isn't it time to move towards solar and set an example to rest of the world, I guess, if India, if not the world? I would rather like to see a solar farm at the entrance, not the substation from TNEB, Tamil Nadu Electricity Board, for those who are not local in Auroville, which produce electricity from coal and nuclear energy. Would you like to answer this question?
Yeah, I can try to answer. I mean, we have presented already that the energy that Auroville will generate will come 100% from renewable sources. So we are not connected with TNEB eventually, not for energy. It is for another reason. Just as I mentioned that the clusters within Auroville will never have a complete 100% match between what they generate and what they demand. That same thing applies to the state as a whole. So let us assume that tomorrow Tamil Nadu state is 100% renewable. Let us assume that for a minute. At no point of time will, in say Viluppuram or Kodulu or Auroville, the solar energy generated match exactly what at that particular second or minute that particular place needs. It will never be the case. So you interconnect to basically absorb these demand supply gaps. That is the reason why we wrote, why Ponnusamy also wrote in his presentation, you need to remain connected to the public grid, but for a different purpose. No longer to consume, but to balance. And a city of 50,000 or township is still very, very small. Even a place like Pondicherry, which has what, maybe 1,900,000, would not be able to be a standalone energy unit disconnected from the grid for the reason I just gave. I can give you a very concrete number for that. I once calculated, you have to excuse me, it was a back of the envelope calculation, but nevertheless, suppose we want to get disconnected from the grid of Tamil Nadu by 2025. Because sometimes people indeed walk into our office and say, why can't we disconnect? So I always tell them, please sit down and open your checkbook. Because if you have to disconnect from the Tamil Nadu grid, we would need a huge storage, right? So I calculated for 2025 with a population that would be, present population, but a little bit more. what will be needed in terms of investment in storage for just 5 days of storage. That is 97 crores, 970 million rupees, which you have to do every 7 years because storage does not last 25 years like solar does, in addition to the solar investment. So definitely you need to remain connected to the grid. You see, sometimes I believe we are against the wrong thing. Don't be against the grid or against the roads. Be against the polluting traffic on the road and the polluting energy that passes through the grid. But the grid itself is a very useful thing to have. So that is why we need to remain connected. And about that ugly substation, yes, substations are indeed ugly. But actually, there is a plan to have an indoor substation. When the moment we cross 15,000 people, then we can apply to TNEB to have an interface at 110 kilovolts, not even at 11. And then we could build a very compact indoor 110 by 11 kV substation. And then hopefully the ugliness will not be there.
I would like to add something also to that question, if I can. See, first of all, Auroville produces already right now more green energy than the energy it consumes. But because Auroville is in a low wind area, we had to place our wind generators into areas where there is a high wind velocity. And then, for example, one wind generator, fully 100% of its produced energy is wheeled into Auroville. That means we feed the electricity into the TNEB grid where the wind generator stands. It's near Coimbatore. And we pull it out again in Auroville and we put it into our owned grid, high tension grid, where Ponnusamy and Toine are working hard to enlarge it. And because this process is so slow, and because we don't have enough consumption, we cannot add a second generator. We have more wind generators at hand, but if we would wheel from a second wind generator, and then we cannot consume the energy in Auroville, then we lose it. Then we have to sell it, the surplus, to TNEB, and we get hardly anything for it. We get 2 rupees for it, while we pay 9 rupees for our electricity bill. So the main reason why we are not yet able to have more green energy made, even in Auroville, we have a plan, Varuna had a plan of putting up a solar plant in the industrial zone. But right now it didn't make sense, or it doesn't make sense, because we would have a surplus production in the peak times. That means we would have export to the grid, and the rules and regulations of exporting to the grid are so unfavorable that it just makes no sense. So once our internal high tension grid is big enough to absorb more energy, then we can feed in more energy. But right now it is not there. And most of the households and units, they are in areas which are not connected to this internal grid, and that is a problem. Secondly, I want to say something to the storage system. Toine just now mentioned that storage lasts for 7 years. There are different types of storages. If you have a battery storage, then that, of course, lasts only for a certain time period. And then you have a lot of problems with polluting materials, with all these lead acid things. The cleanest way of energy storage is, of course, the hydropower storage, which is also the most efficient. And Toine, you may remember when Toine and myself, we went and visited some power storage systems here in the Bavarian forest. And we went into one room where there was a very small turbine, and it was still running, and it was from 1918. It was running for more than 100 years, and still it is running. So if you have the hydropower storage, you have once an investment which is comparatively small, and then it is indefinite. These turbines, they have hardly any wear and tear. So I think we should put our focus on hydropower storage. And there, the reason why we don't have it yet is very clear. The concept which we had also proposed in several general Auroville meetings always was that we have the Matrimandia Lake, and we have a hill with the earth from that as a backbone of also the energy storage. And it has taken us so long. Finally, now we have started with the lake, and I hope that all the elements which are required to have our own energy storage are now coming together, and hopefully soon we will have everything in place. But it's not a question of that we don't want or so, it's a question that we are too slow in our whole development.
Thank you, Michael. So these questions have been replied. Is it? No? No, this is the one. So I'm trying to see if there is extra question here. Rade, can you help me? Is there any other questions?
Yeah, there's just the one that you're seeing there. There's two parts to it. So the second part, isn't it time to move towards solar, which has probably been addressed. Yeah. Okay.
So we have,
Yeah.
okay, so we have taken up all the questions from the audience. So I had prepared something also. My first question, since we have a new major actor which has come on the scene of Auroville, which is the government of India, how this new arrival can help and speed up the process. Can somebody would like to take that question?
Well, I do hope that with the government of India's involvement, at least the township infrastructure can be accelerated, because the government of India may not be able to fund each and every project, but usually governments do fund, in any case, infrastructure in cities. So if we can accelerate the development of the electrical infrastructure, the water infrastructure, the mobility infrastructure, and create a backbone in which projects can be plugged in as and when they come. So you don't make the whole infrastructure for 50,000, for sure you don't do that, but you create the backbone, like the high tension cable that he is installing is like a backbone, and you connect different zones and sectors to it as the town develops. So I do hope that that part of the township development can be accelerated.
Someone else would like to add something?
Yeah, just to add to what Toine said, even for the infrastructure, we need to be very careful that we develop an infrastructure which is not carbon intensive in the long run, and the solutions which are not going to take people away from alternative solutions. Okay? So, for example, what is happening now in the whole country, we are only focusing on road, and that is not a very good idea, because more roads means more vehicles, whereas the government should be focusing more on public transport, whether it is rail and other modes of transports. But a lot of focus is now given on road transport. So in Auroville, if we are planning to have any infrastructure, we should be thinking about how do you bring in more public transport. At the same time, I mentioned about bicycle even. You need to have proper bicycle lanes where people feel safe to ride. Okay? And preferably, and it's a place where you already have shaded areas, so that's not an issue, but you need to think about the safety of people. People should feel all right. Okay? With dirt road, it's all right only when you're really motivated, you would go for it. Otherwise, it's not a very good way to do it in a big city. Thank you.
Maybe it is good to mention that Auroville has in the last couple of years made quite a good transition to e-cycles. By chance today is Kinesi Open House Day. I went there in the morning. And under a scheme which is called KIM, Kinesi In-Kind Mobility, there is already more than 300 now on the road. So that is basically an attempt to get Aurovillians and visitors to move from the fossil fuel two-wheeler to the e-two-wheeler. So infrastructure indeed must facilitate a sustainable future. Again, the same thing what I said about the grid. Don't be against the grid. Be against the dirty power going to the grid. Don't be against the road, but be against the road which is used wrongly for private transport. Make it for public transport.
I may add something also. We have been looking always mainly at wind energy and solar energy. Right now, solar energy is very much in focus. But I think there is one energy source which here in the West is very prominent also, that's biogas. And definitely Auroville should also have a biogas plant. All the waste materials and especially the organic waste, even wastewater treatment, if you do it in a proper way, you can make biogas out of it. And a biogas plant, you can control. You don't depend on the weather or anything. You can let it run at its highest output whenever you want, when the other energy sources are not coming up. So we should also keep that in mind, that we add to the mix of energy sources biogas in Auroville.
Very good. I have one more. So the theme of the webinar is the future of energy in Auroville. We have addressed something who looks like for me the near future. So I wanted to bring modern Aurobindo into the picture and see about the far away future. So something which disturbs me a little bit is this idea that we will have to go for, sure, some technological advancement, but some austerity plan also regarding the use of energy, because we are facing environmental problems. But I'm thinking, has not the divine thought about it and kept some invention and discovery along the line who could answer to the exponential growth of population still happening on Earth and the needs for humanity to express, produce, and live. And then I was thinking about Sri Aurobindo's writing and the fact that, I'm paraphrasing, and if I'm wrong, you tell me. He said that at one time science will rediscover the ether. And I was thinking about some of those people who speak about free energy or 0 point energy. And I think I read somewhere, heard somewhere that 1 cubic centimeters of empty space in space or here would have enough energy in it to evaporate all the oceans of the Earth. And I was thinking, will there be one day that you know of, maybe, a way to extract that energy in a non-pollutant way, but then we will have free energy, illimitable, and we could just enjoy our planet. So this concept of ether to be rediscovered by science, I was wondering if that was not a hint that Sri Aurobindo was given for future discoveries about energy.
You talked about austerity plan. We are not talking about austerity. We're talking about what is the need. And it's not only about energy. For everything, we have to define very well what is your need. Because as Gandhi has said, there is enough for everybody's need, but not for everybody's greed. So when you go beyond a certain point, you are going to have some sort of impacts. And for example, simple way I'm talking about, we are going to use air conditioning. The question is, can you think about air conditioning an area which is much smaller compared to air conditioning a big space? We're using fans, we're using efficient fans. If I'm alone, I don't need to use a ceiling fan. I can have a fan near me, and with just about 4 or 5 watts, I can get my comfort. I don't need to use a 30 watts fan. So we do have this type of alternatives. I look at lights outside, they're burning whole night. You can have a sensor-based lamp. Technology is already there. It's a question of deciding to go for that alternative, by which we'll reduce, we only use what is needed and nothing beyond that. So that's not an austerity plan. It's the same thing with the food. There's a lot of food wastage. How do you avoid that? Okay, so it is possible to meet all our needs without any austerity plan. We travel without knowing why we're traveling. So some people, there's something called rebound effect. When we make efforts, we have renewable energy, and we must use it because we have so much of it. Okay, where in my house, I produce about 30 to 35% more electricity than what we need. And yet we don't use the air conditioner unless it's really required. The trend now is you come inside a room and just switch it on because it's already there. So the question is, if the outside conditions are favorable, why should I go for an air conditioner? So that's where the behavior and lifestyles are very important. Okay? So we're not talking about austerity. We're talking about going for what is actually needed, nothing beyond that.
Actually, since you talk about a hint that Aurobindo has given, Aurobindo has given much more than a hint for the ultimate solution, which is transformation. So once the transformation takes place, even the needs that Brahmanand has spoken of won't be there anymore, the needs of the vital and the physical. So I always believe that we have been given a sort of a time frame, and we don't know how long that time frame is. Maybe it's good that we don't know, within which that transformation has to take place. And all these things about ecology and sustainability are just to give space for that real solution to come. I mean, and that also applies to Auroville as a whole. Auroville is not an eco-village or an eco-town. Auroville is meant to be an instrument, a laboratory revolution where the real transformation and change is supposed to take place. But you automatically come to sustainability in that type of a consciousness. So I think we have to understand that the ultimate solution is not solar or wind, or the ultimate solution, if you want to use that word, is the transformation. And there, about that, Aurobindo has given much more than a hint.
Anyone would like to add something? Michael, or any last comment before we close
Okay,
the seminar?
I can add something. The main purpose of Auroville is, I think, that we have a collective working on our consciousness and develop a new type of society. And Auroville is actually the only large-scale project which is working at developing a new form of living together. And when you look at the world at large, then the main culprit of also our utilization of resources and all that is the monetary system. The monetary system is a system where money generates more money and more economic speed and more growth of the economy. And now already the niche of our species is full, it's bursting. So one of the solutions would be if we switch from the monetary system to a non-monetary system. Right now, it's like that. The person who has most money, he can have the best looking wife. He gets the most respect. He has most possibilities. In a non-monetary system, all this is not there because there is no money. So then maybe not the most richest fellow who has the biggest car and the biggest TV screen, but then maybe the guy who is most understanding will have the best wife. And then when the whole motivation switches, then I think also all this overconsumption will drop, because then it has no more meaning. And when you see our economy right now, all the articles that we produce, whether electrical equipment or everything, is manufactured in a way that after a few years it falls apart and you have to buy a new device, and there is so much wastage. Then all the advertisement branch, it tries to create needs which are not there so that the products are consumed. All these criminal delicts, the courts, everything would fall away once the money system changes to a non-monetary system. So I think if we can focus on changing our social system to a non-monetary system, we could advance very much. And this is something very concrete. Of course, the final thing is that what the mother in Sri Aurobindo said, that we have to replace rules and regulations by a direct access to a higher consciousness. But that is a very difficult thing to achieve. But to switch from a monetary system to a non-monetary system is something very concrete, which we could achieve in Auroville if we only want to. And it's surprising how much resistance comes up when one mentions that and one tries it out. But the fact that with electricity, we have proven that it's not ending in a disaster if you switch to a non-monetary system, demonstrates that absolutely possible. And I think we should really focus on this aspect and try with all the resources, but starting electricity, water, and all that, to come to a non-monetary system.
Thank you, Michael. I would like to thank all our panelists. Thank you very much. It was extremely interesting. I would like to thank Rade and Vladimir also, who have been supporting our webinar, and the audience who has followed us and asked questions. And we'll just close with one moment of silence to thanks Mother and Aurobindo for accompanying us in this webinar. Thank you and goodbye.
Thank you.
Thank you all. Namaste.